Hi, I'm Rudranil Das Sharma, and today we will do a prediction using supervised machine language, and it's a beginner level. And this is to predict the percentage of a student based on the number of study hours. That means to find if a student studies for a certain amount of hour, how much will he or she score? And if the data follows a linear relationship, can we predict the same? That is the main aim. Can we predict that how much a student will score if he studies for some amount of time? And I will do the same in R. Right. Now first, it is we set the working directory. Then this data is in an Excel format, so we have to import that thing. To do that, we have to get the library read Excel, and then I gave a name student dedication read Excel file students time.xls. Once I do it, see I got a students file. Now if you see, it is a very simple basic. It has got 25 rows and 2 columns. So first column is hour, second column is score. It is something like if a student studies for 2.5 hours, he scored 21. Somebody studied for 5.1, he scored 47. Somebody studied for 3.2, he scored 27. Somebody studied for 8.5, he scored 75, and so on and so forth. Right? So can we predict that if he studies for a certain amount of time, how much how much he will score? So first we see the summary. The summary is minimum 1.1 hours, first quartile is 2.7, median is 4.8, mean is 5.012, third quartile is 7.4, maximum is 9.2. That means the student has studied maximum is for 9.2. And similarly the score, it is minimum is 12, first quartile is 30, median is 47, mean is 51.8, third quartile is 75, and maximum 95. That means the minimum scored by a student is 12 and maximum scored by a student is 95. Now mean is the average, median is breaking the whole data into two half and the middle point. Now what is first quartile, what is third quartile, I'll come to you. I'll come back on first quartile and third quartile. Now what is the structure? The structure is both are numeric in nature. Now we attach this student dedication, this data. Now why did we attach otherwise if we don't attach it, so every time we have to write like the students dedication dollar hours or student dedication dollar scores. To avoid that thing, we break the thing so that we can use hours and scores individually. Right. Now we import the library ggplot2 because we will be requiring it. Now we see the box plots. Okay, very fine. This is our box plot. Now just I'll do one thing. I will show you what this thing. See, if you see here, this is okay. Now if you see, the minimum is 1.1, some, so it will be lying somewhere here 1.1, and the maximum is 9.2 for hours. This is maximum is 9.2 for hours. Some it will lie some place here. The median is 4.8. Now this is your 4.8 median. This is your median. That means if you break it down, the whole data set into two, this is the middle point. Average is 5.012, so the average is somewhere 5.012 must be somewhere here, and this is your first quartile. This is your first quartile. That is first quartile is 2.7. This is a first quartile, 2.7. And this is your third quartile. Third quartile is 7.4. This is 7.4. So this is first quartile, this is third quartile, right? So we'll see it, we'll see more. Okay, now if we see the box plots for scores, the box plots for scores is again the same. Box plots for scores is again the same. If you see again box plots for scores, right, the minimum is 12. The minimum is somewhere here 12, and the third quartile is 75, the first quartile is 30. So the first quartile is 30. This is your first quartile. Okay. And the third quartile is 75. This is your 75 range. So this is your third quartile limit. These are the limits. Okay. The median is 47. See, this is 40, 41, 42, 43, 47, 47 is somewhere here. And the mean is something a little greater. The mean will be somewhere here, 51.8, right? Okay. Now, once we have done this thing, we want to see a little better graph. Okay. So this is how, now this is how you will see. This is okay. So this is the graph. See, this is okay. Let me first explain this thing. This is ggplot data. The data is student dedication. The student dedication data you have taken. Aesthetics. Aesthetics is X is factor. I have put factor 0. Factor 0 is nothing here, right? 0 factor. Okay. Y is hours. This is the hours time. 2.5 to it has gone 9, 10. Then is geom jitter. Why is geom jitter? Geom jitter is to get all these points, right? To get all these points. And then is geom box plot. Alpha is 0.5. Alpha is 0.5 means those dots inside are also are transparent. Basically, it is just to make it transparent, right? So we made this thing, and now you see, if you see this, uh, see, this is the third quartile, this is your first quartile, this is your median, right? And maximum range. Now the question is something, are these some outliers? That means this is very high, it is out, it is crossing the range. Is it an outlier? Is it an outlier? We have to see those things, we have to calculate, we have to see if there are some outliers are there or not. Okay, then we did the ggplot for scores. First we did for hours, and now for scores. Now in scores I just added one more thing, aesthetics color is equal to red. So once you see these things, you can also use this. So aesthetics color is equal to red. Now see what had happened, the colors of this, the colors have changed to red. This is red, right? And these are transparent, right? So I have changed again the score. This score, is the score an outlier? Oh, okay, here is some, is this score an outlier? So we have to see if there are some outliers or not. Now how to find the ranges in this interquartile ranges, how to find? So we do the interquartile ranges, and we see the interquartile range is 4.7. So to find the outliers for hours, for the third quartile, it is third quartile plus 1.5 into 4.7 IQR range. The range is 4.7. So we will see if there are any outliers. Okay, right? And here we go, 14.45. No, nobody has gone. It is 1.1 to 9 something. It was 9.2. It was 9.2. So there is no outlier on higher range. On the lower side, let me see if there is any outlier. Even it is minus 4.35. No, so we don't have any outliers in hours. Similarly, we check for scores. IQ scores is 45. Interquartile range is 45. Then the outlier is 142.5, and this is minus 64.8. So no outliers are there. So we don't have to think anything. We don't have to use anything. Now we do a G-plot. G-plot is ggplot. Data is students' dedication. Aesthetics is hours. Y is scores. Now we want to see the relationship. This is geom point. This is geom smooth. The method is linear method, and AC is false. AC is basically to display the confidence interval. I'll show you. So if we do it, now we get this plot. Fair enough. These are the hours, and this is scores. They have scored, somebody who has studied for 2.5 hours have scored maybe 23, maybe 26, 27. Somebody has studied for 5, maybe he has scored, somebody who studied 4.8, he has scored maybe 52. So these are the scores, and this is a line. So generally they are following a regression pattern, a linear pattern. They are following a generally a linear pattern and just falling outside, and some are very close, right? Now, why is this geom point? I'll show you. If this is not geom point, what happens? If this is not geom point, what happens? That you don't get anything. You generally you don't get anything. You just get a blank. So you need to have the geom point so that you get those points. Okay. Now we again do. Now this is false. AC is what? Display confidence interval. What is confidence interval? That how much confident I am. So it will be 95% confident that okay, this point, this marks will fall in that range. So let me show it to you. Gplot2, gplot, yes, gplot2, sorry. Now, yeah. Now see, this is a 95% interval. That means with 95% confidence that I can say, okay, see, these are the points which are falling inside this 95% confidence. So it was, say, if it was 80% confidence, everybody would have fall in this range, or if it was 75, so everybody should have been in this range. So with 95% confidence, I can tell, yes, some points are there. That means they are generally following a trend. Now we do a histogram, right? Excellent. Now see, if you see the histogram, see, this is basically 10 to 20, there are 2 students. 20 to 30, there are 7 students. 30 to 40, there are 1. 40 to 50, we got 3. 50 to 60, we got 2. 60 to 70, we got 3. 70 to 80, we got 2. 80 to 90, we got 4. And 90 to 100, we got 1. So it is 2 plus 7, 9, plus 1, 10, 13, 14, 15, 16, 17, 18, 19, 20, 24, and 25. So these are the distribution of 25. So some 10 to 20 is 2 students. So maybe somebody has got 12, somebody has got 18. That I don't know. But this is the basic range. Okay. Now let me see. I'll do the library R companion because I want to see plot a normal histogram. So normal histogram, yes, this is it. Again the same thing. It's the same thing, but only thing is that now we got a curve, a bell curve. Is this a normal distribution? Is the scores frequency, is the frequency of the scores is normal or not? We want to see that. We want to check it if there is any skewness in that. So we will have to check all those before we do the action of linear model. So to check the skewness, now is the library. Now now we got the library E1071. Then we check the skewness for hours. The skewness for hours is 0.16 and skewness for scores is 0.1728. That means there the skewness can be 3 types. One is right skewed, one is left skewed, and one is normal distribution. If the range is from -half to -1 and +half to +1, it is a moderate skew. So just to so that you remember, I'll just write this thing: -1/2 to 1 and +half to 1. It's a moderate. It's moderate skewed. So we see it is 0.16, 0.17. That means they are tending towards 0. So it's a moderate skew. If it had been -half to sorry, this just got it wrong. This is -1. So if it is -half to -1, and if the range was beyond this, beyond -half, then it would have been left skewed, and if it was beyond this, it would have been right skewed, and between it is moderate skew. Now we do the modeling. Linear model, since it's a linear regression, model 1 linear model, scores versus this thing, and now we get the summary. Now if you see the summary, you have to understand 5 things which you should you should know. First is intercept 1.6430. One. Second is hours, is given hours, because hours scores is dependent on hours. That is why it is not, hours is not dependent on scores. Scores is dependent on hours. So hours 9.9036. Scores dependent on hours 9.9036. So the equation is 1.6430 plus 9.9036 hours, right, into hours. I'll show it to you. Okay, the third point is to this p value. It is 2 e to the power minus 16. That is very, very negligible, within 0.05 range. So yes, it is acceptable. Then we see the multiple r squared 0.9551 at adjusted r squared 0.9531. Now what is multiple r square, what is adjusted r square, that we have to go in a second different class. But for the time being, for this, you just remember, since this value is very high and they both are very close, so it's a good, it's a good linear model we have got. So fantastic. So now what I was talking about, if we have this 1.6430 plus 9.9036 into somebody, I say have studied for 5.6 hours, how much score will he get? So it will be around, say, 57. So we have predicted, actually what we have done, we have predicted that somebody is studying for 5.6 hours will score around 57. Somebody says studying for 8 hours, yes, 7.7 hours, so he will score around, say, 77.9, 78%. So that we can predict through this linear regression model. So this was it. Thank you. I'm very sure you have liked it, and thank you so much.